In pursuit of a better tomorrow, there are many advancements in technology in the modern-day world. Needless to say, many innovations and discoveries are being made that aim to transform how we live and commute. In today's video, we will look at contemporary Amperex Technology Company Limited (CATL), the world's leading lithium-ion battery manufacturer, and discuss its solid-state batteries, which are an alternative to lithium-ion batteries. This video will highlight the potential impact of this technology on the battery market, exploring how CATL is pushing the boundaries of PHEV and REV battery technology with their latest breakthrough. We're diving into how this game-changing innovation blends efficiency, power, and sustainability, and why it might finally solve the challenges that have held solid-state batteries back for so long. Many of you might not know that CATL, the world's largest electric vehicle battery maker, was founded by Robin Zeng in 2011 and has been a major supplier of lithium-ion batteries for electric vehicles. These batteries are used by some of the world's biggest electric car makers, such as BMW, Hyundai, Mercedes-Benz, and Tesla. CATL's cutting-edge electrochemical energy storage products have made a significant impact, powering a wide range of applications across diverse sectors. These advanced energy solutions have been seamlessly integrated into large-scale industrial operations, bustling commercial hubs, and residential areas, offering sustainable and reliable energy storage options. But CATL's innovation doesn't stop there. Their products are now expanding into exciting emerging sectors, including providing backup power for vital base stations, ensuring uninterrupted service with UPS, uninterruptible power supply systems, and enabling off-grid solutions for remote locations, including islands and isolated systems. Moreover, CATL is revolutionizing energy management in the tech world by introducing intelligent charging stations, specifically designed for charging and testing optical storage systems. This cutting-edge approach promises to enhance the efficiency and performance of the entire energy ecosystem, fostering new possibilities for clean energy integration and boosting energy resilience in both urban and off-the-grid environments. With this continuous expansion into futuristic energy applications, CATL is shaping a smarter, greener, and more sustainable world. In fact, in 2023, 1 out of every 3 EVs globally was powered by a CATL battery, with over 11 million CATL-powered electric vehicles cruising around the world. Since 2020, CATL has been supplying LFP lithium iron phosphate batteries to Tesla for cars made at its Shanghai plant. In this episode, Nikolai is joined by Robin Zeng, the founder and CEO of CATL. The world's largest battery producer, CATL, is seeking a second listing in Hong Kong to increase its global presence and improve overall competitiveness. While the technology is still in its early stages, CATL's progress has been impressive. New reports confirm that CATL has entered the trial production phase for its new solid-state batteries. Solid-state batteries offer several advantages over conventional lithium-ion batteries. The prolonged charging times of traditional batteries, ranging from 1 to 12 hours depending on the charger type, are far from convenient compared to the few minutes it takes to refuel a gasoline or diesel vehicle. On the other hand, ultra-dense batteries boast an impressive energy density ranging from 300 to 500 Wh per kilogram, doubling the capacity of traditional lithium-ion batteries. CATL is not alone in its pursuit of solid-state batteries. Some companies have instead looked to semi-solid-state batteries, which don't feature an entirely solid electrolyte. SAIC Motor, the parent of the MG and LDV brands, recently revealed its IM-L6 sedan with a 130 kWh semi-solid-state battery. QuantumScape, QS, is at the forefront of solid-state battery technology and is a potential threat to traditional battery technology in the electric vehicle industry. Toyota is shifting into high gear as it focuses on bringing solid-state batteries into mass production. It plans to have them commercially available by 2027 or 2028. The automaker's first solid-state battery promises to revolutionize the electric vehicle experience, offering an impressive 621-mile driving range and an 80% charge in just about 10 minutes. This leap in battery technology could redefine the electric vehicle landscape, ushering in faster, longer-lasting, and more efficient rides. Meanwhile, in January 2024, Prologium made history by launching the world's first gigascale solid-state battery factory, with mass production expected to commence by 2027. This signals the start of a new era where solid-state batteries move from concept to reality. If they deliver on their promise, this will make solid-state batteries obsolete. The race is on, and with various manufacturers ramping up their efforts, it's anticipated that the solid-state battery market will hit full-throttle production by 2026. But here's the burning question: Could CATL, the world's largest EV battery maker, be the real game changer? In a bold move that has sent shockwaves through the industry, CATL has slashed its lithium mining targets, signaling a potential shift in its strategy and a strong bet on the future of solid-state technology. As the buzz grows, it's clear that advancements in solid-state batteries hold immense promise for the electric vehicle revolution. A truly great product isn't just about the spark of innovation in a lab, it's about how it transforms everyday lives and stands up to the real-world demands of users. Solid-state batteries may very well be the breakthrough that takes electric vehicles to the next level, shaping a cleaner, faster, and more efficient future. CATL leaves the exact capacity of the battery undisclosed in its product presentation. However, the manufacturer said it should be possible to charge the energy necessary for a journey of 600 kilometers within 10 minutes. This means that a 1-kilometer range would be charged to the battery every second. A full charge for a range of 1,000 kilometers can be purportedly achieved in 16.6 minutes. Discover the launch of the CATL Superhybrid battery and dive into its impressive features. Imagine charging 600 kilometers of range in just 10 minutes. Yes, you heard me right, CATL is making this possible. This game-changing innovation is set to revolutionize energy storage and challenge global competitors in the race for battery dominance. China's battery and car makers have united as part of a government-led drive to commercialize all solid-state batteries, challenging Japan and the West. Many large car manufacturers are investing directly or through other companies in solid-state batteries. Do you ever feel limited by your electric vehicle's range? Be assured you are not the only one. The world's largest battery manufacturer has revealed a new battery for plug-in hybrids, and this highly anticipated battery will be revolutionary. By Toyota, it is being reported by numerous media outlets and is expected to initiate the journey to market dominance and power the future of batteries globally. Electric vehicles, EVs, and the battery market are projected to reach $135 billion by 2027, with a compound annual growth rate of 25%. CATL's battery combines lithium iron phosphate (LFP) cells with sodium-ion cells, offering faster charging speeds and improved performance in cold weather compared to traditional LFP batteries. PHEV and REV typically only extend between about 50 to 100 kilometers. This limitation can be particularly challenging on the expansive roads of the Midwestern United States or the Great Australian Outback. Typically, we require between 1 and 3 hours to fully charge our EVs, sometimes even more. However, with CATL supercharging technology, charging speed exceeds that of most long-range electric vehicle models with ranges of over 600 kilometers. CATL longevity batteries are all about endurance, designed to last a long haul with a lifespan of up to 8 years and 800,000 kilometers. Compared to regular batteries, this one experiences reduced power decay over time, meaning your electric vehicles will stay juiced for longer. That translates to durable cars with a higher resale value. CATL's research and development team is working tirelessly to improve the condensed battery's charging capabilities, ensuring that it can recharge in minutes rather than hours. This game-changing development will be of tremendous advantage, not only in the transport sector but also in other areas as well. For instance, consider the efficiency of other alternative renewable energy sources like solar or wind. Having durable and more efficient means of storing this energy would reduce the community's carbon footprint and lower its energy costs in the long run. Materials they're researching for these solid electrolytes are more abundant and less toxic than the ones used in lithium-ion batteries. Some of them don't even need the rare earth elements that are often, well, let's just say, not great for the environment. Do you think this is doable? Mass production involves overcoming significant engineering and cost hurdles, which is why I am a bit skeptical. But let us say I will believe it when I see it. Try to imagine being out in a negative -1 degree Celsius environment like Alaska and being able to charge your electric vehicle to 80% in less than 10 minutes. Wouldn't that be incredible? Cold weather often poses a challenge for electric vehicles, with the battery capacities of REVs and FEVs typically declining by 15 to 30% in low temperatures. In regions like Northern Europe, the impact of extreme cold can further heighten consumers' concerns during travel. However, CATL batteries are uniquely designed to discharge in extremely cold environments as low as -40 degrees Celsius. They'll charge at -30 degrees Celsius and still provide strong power output at -20 degrees Celsius. This ensures stable performance even in harsh conditions. First and foremost, we need to understand that the three essential components of any battery are the anode, cathode, and electrolyte, and these components form a circuit that stores and releases energy. The anode is where electrons flow out during discharge, the cathode is where they flow in, and the electrolyte facilitates the movement of lithium ions between the two components. In traditional lithium-ion batteries, the electrolyte is a liquid that allows lithium ions to move freely between the anode and cathode. However, it also poses risks such as thermal runaway and fires. In other words, traditional lithium-ion batteries have a limited temperature operating range, affecting their performance in extreme conditions. What has CATL done in their condensed battery, and how have they redesigned other parts of the cells? Solid-state batteries aim to solve this by replacing the liquid electrolyte with a solid one. This design provides higher energy densities, the amount of electrical power a battery can store with respect to its mass, and improved safety. However, it comes with its own set of challenges. Solid-state batteries use lithium metal anodes, which are lightweight, enable higher voltages, and can store more lithium ions, leading to extremely high energy. Lithium-ion batteries always need to have a 30 to 40% charge. That's why when you get on a plane they ask you to take out your batteries if you're going to check in a bag. It's because they can become unstable and catch fire. Imagine a future where electric planes can fly longer distances on a single charge, reducing the aviation industry's reliance on fossil fuels and lowering its carbon emissions. At times, it is very easy to criticize achievements without understanding the enormous effort that has been put into the mass production of CATL's solid-state batteries, which face significant challenges. Battery chemistry, structure, and the development of advanced charging algorithms will be needed to ensure optimal, safe, and efficient delivery of high currents to the battery. Biomimetic electrolyte interfaces go a long way toward addressing the challenges of efficiency and longevity. However, honestly, there is still room for improvement. CATL's new interface layer is strong enough to withstand even the powerful dendrites from lithium metal anodes in the condensed battery. While CATL's solid-state batteries are paving the way for a revolutionary future, it's important to acknowledge the immense challenges that come with such groundbreaking innovation. Overcoming these hurdles requires cutting-edge technology and a relentless pursuit of perfection. So how does CATL plan to tackle the limitations of traditional batteries and reshape the future of fast charging? Fast charging is now a reality as CATL's innovative batteries prepare to redefine the EV industry and set a new standard in battery technology. In the realm of electric vehicles, the limitations of traditional lithium-ion batteries loom large, posing significant challenges in terms of energy density, charging time, and overall performance. While these limitations may be tolerable for smaller applications like wearable technology or smartphones, they become glaring issues when applied to larger-scale endeavors such as electric vehicles. The current challenge in traditional batteries is cycle longevity, the number of times a battery can be charged and discharged before its performance begins to degrade. Conventional lithium-ion batteries have a cycle life of around 1,000 cycles, limiting their long-term performance. CATL batteries intend to fix just that. The company's researchers are exploring new materials and designs to further enhance the battery's longevity, ensuring that it can withstand thousands of charge-discharge cycles without significant degradation. According to a new local report, their design intends to increase the life cycle to 5,000 cycles, a 500% increase. You can guess what that would mean in the EV market. This means electric vehicles equipped with CATL's technology could last longer and require fewer battery replacements, reducing the overall cost of ownership. Traditional cathodes have energy densities of around 250 Wh per kilogram, limiting the overall energy density of the battery. Still, CATL's ultra-high energy density cathodes push this to 350 Wh per kilogram, a 40% increase. Imagine your EV adding a range of 700 kilometers in just 10 minutes of charge. Wouldn't that make your journey more straightforward and efficient? According to CATL's SCA1 Chief Technology Officer, the battery known as FREO is the world's first hybrid battery with a range of over 400 kilometers, estimated at 249 miles. Here's where things get exciting. Traditional lithium-ion batteries have charging rates of around 1C, limiting the speed at which they can be recharged. However, CATL's advanced charging algorithms and optimized battery chemistry allow for charging rates of up to 5C. This means the battery can be recharged in a fraction of the time, making electric vehicles as convenient as gasoline-powered cars. Solid-state batteries, in theory, should increase safety, energy density, and charging rates while lessening the need for certain volatile liquids in production. Sodium batteries are larger and have a lower energy density than lithium-ion batteries. Battery fires have also been an issue dogging lithium-ion technology, so experts claim solid-state batteries will be much safer. At the 2024 International Beijing Automotive Exhibition, CATL unveiled the Shining Plus battery. This pioneering innovation sets a new standard with an impressive range of 1,000 kilometers, the equivalent of traveling from Paris to Berlin without needing to charge halfway. It establishes itself as the world's foremost LFP battery to attain a 1,000 kilometers driving span and 4C superfast charging capabilities. The groundbreaking technology lets you rapidly recharge or discharge your electric vehicle for a 600 kilometers journey in just 10 minutes. This battery maintains its exceptional performance even in frigid conditions, ensuring robust operation and rapid charging speeds regardless of temperature drops. In extremely low temperatures, this battery achieves a 50% increase in charging efficiency at -20 degrees Celsius. Effectively, even with low battery levels in the cold, you can still experience the unyielding speed and thrill of 0 to 100 km per hour. Unfriendly cold solid-state batteries, while highly promising for their safety and efficiency, are currently expensive to manufacture due to the complexity involved in both their handling and production processes. The average temperature of the Arctic region in winter is -31.86 degrees Celsius, so having a battery capable of charging and demonstrating strong adaptability to extreme environments will be quite profound and will continue to show human ingenuity and relentlessness. Additionally, despite their advantages, these batteries face the limitation of requiring replacement after extensive cycles of charging and discharging. This reduces their long-term practicality and poses a challenge in terms of cost-effectiveness and sustainability. However, with ongoing advancements such as CATL's biomimetic interface, there is hope for improvement. GSAN believes that the theoretical potential is enormous, still it needs to be practical and attainable. Stability under real-world conditions is another critical challenge. Contemporary Ampex Technology Company Limited (CATL) story is one of ambition, innovation, and the relentless pursuit of a better tomorrow. While these breakthroughs in battery technology are undoubtedly impressive, there's one question that still looms large: can they truly overcome the roadblocks of cost and sustainability? With major players like CATL pushing the limits, the race to unlock the full potential of solid-state batteries has never been more intense. Let us remember that we are not just witnesses to history but active participants in shaping the future of energy storage and utilization. As we look to the future, we should not forget the roles we play in achieving a greener and sustainable environment. I imagine that when the major players have solved the challenges, then we will get some very concrete developments about the future of batteries. Established players like Tesla and Toyota have been making strategic investments, aiming to dominate the market with solid-state technology. Keeping up with the scale of growth of the battery market will probably be one of the largest challenges for solid-state batteries in reaching a large market penetration. The biggest challenge is cost. These batteries are set to revolutionize the EV industry. Still, currently these batteries are more expensive to produce than traditional lithium-ion batteries. With demand for lithium-ion batteries projected to soar in the coming years, CATL's announcement shocked both the stock market and the EV industry. Lithium stocks skyrocketed overnight, leaving many investors wondering what the future holds. Energy storage will transform everything from your smartphone to the very power grid that keeps our world running. CATL, with a 36.7% market share, has quietly been working on something far more revolutionary. These batteries could reshape industries beyond electric vehicles, including renewable energy storage and electric aviation. With CATL's innovation, solar and wind energy can be stored efficiently and reliably, providing a stable power supply. In this modern era, the chase for carbon neutrality is essential, and the use of low-carbon emission raw materials is critical in the production process. Solid-state batteries remain expensive compared to their lithium-ion counterparts, posing challenges in the early phases of production. Mr. Zen was quoted at an automotive exhibition in Japan, "I mean, if this is not a sales pitch, I do not know what is." As with any new technology, success usually comes with scale, which solid-state battery companies have yet to build out. Surely, CATL is paving the way for next-generation battery technologies to become commercially viable. As I see it, eventually, lithium batteries may not look like batteries at all, and only the innovative battery solution will stay. Consumers and manufacturers alike are sensitive to cost. As such, CATL is investing in advanced manufacturing technologies and economies of scale, aiming to drive down the cost of producing the condensed battery and make it competitive with existing technologies. CATL has innovatively developed the directional recycling technology for the resource regeneration process, helping recycle up to 91% of lithium and over 99.6% of nickel, cobalt, and manganese from retired batteries. CATL intends to reduce the cost of producing the battery to $8 per kilowatt-hour, a 20% reduction, which will make CATL batteries more competitive with existing technologies, accelerating the adoption of electric vehicles and reducing the overall cost of ownership. CATL is the biggest battery company in the world. This will likely be the cheapest battery on the market for plug-in hybrids. Challenges persist, particularly in scaling up production and cost-effectiveness. Nonetheless, ongoing research and endeavors are poised to unlock graphite's full potential, propelling battery technology into uncharted territories. Furthermore, solid-state technology heralds a paradigm shift in battery design, leveraging solid electrolytes to enhance safety and energy density. By replacing flammable liquid electrolytes, solid-state batteries mitigate the risk of combustion while enabling higher voltage operation with superior energy storage capabilities. Do you think this can be achieved this year, or does it remain a dream? At times, it is important to know these things before spending $60,000 or $100,000 on a vehicle that is not value for your money, meaning you want to be using that battery as much as you can efficiently while being able to save money. What CATL is doing is nothing short of incredible. The future of solid-state battery technology appears promising, and with continued research and development, we can expect the emergence of more efficient, safer, and cost-effective batteries. As the shift towards sodium-ion batteries gains momentum, we may see a massive change in the market. It's essential to scrutinize the fundamental components driving these remarkable advancements. The silicon anode emerges as a cornerstone, offering unparalleled potential alongside notable challenges. Silicon's allure lies in its exceptional lithium storage capacity, dwarfing traditional graphite. Toyota's commitment to this technology builds upon its history of automotive innovation, suggesting a long-term strategy focused on perfecting the technology before its widespread market launch in 2028. This suggests how the electric vehicle industry is transforming and how sustainable energy is important for a better tomorrow. Ultra-dense battery technology refers to a breed of batteries boasting an exceptionally high energy density. The allure of high-energy density batteries lies in their ability to offer extended operating ranges and improved performance for electric vehicles, such as those manufactured by the pioneering company. I really can't overstate that this ability to use lithium metal anode without the need for solid electrolytes is a real game-changer. With advancements like silicon anodes replacing traditional graphite, these batteries can significantly increase energy density. For example, silicon anodes can theoretically store up to 10 times more lithium ions compared to graphite, which could potentially raise energy densities to around 400 watt-hours per kilogram. I've recently been reading about some of the breakthroughs from Chinese battery giant CATL. When they say they have a new breakthrough, they almost always deliver on it. CATL has been clear that this is not a lab-scale demonstration. They said this is currently operational in a ton-scale electric passenger aircraft, though we have yet to see videos. I hope you now understand why, since its inception, CATL has grown rapidly and become a major supplier of batteries to a wide range of international car manufacturers. Many have said solid-state batteries are an exciting new technology that can improve the existing battery paradigm and open gateways toward new technology developments. I hope this video has given people a bit of education on plug-in hybrid batteries. There is still skepticism, and most people believe solid-state batteries may give mobile phones a longer charge and discharge life and make it safer to use more of the capacity without losing cycle life. Still, until they go into production, it is all speculation. I hope you enjoyed it, and until next time, thanks for watching.